Imagine a civilization so advanced it has conquered every challenge humans have ever faced. Disease, energy, war, death itself. Now point that civilization toward the edge of the Milky Way and ask it to leave. Here is what happens. The galaxy stretches 100,000 light years across. Even at the speed of light, the absolute limit of physics, crossing it would take longer than all of recorded human history 20 times over. But leaving the galaxy is not the same as crossing it. Beyond the final stars lies a void so empty and so vast that the Milky Way itself shrinks to a speck behind you while the nearest galaxy remains impossibly far ahead. The distance does not just defeat rockets. It defeats civilizations. It defeats continuity. It defeats the very idea of remaining human. If this kind of deep cosmic perspective is something you enjoy, do me a favor and tap that like and subscribe button. It genuinely helps this channel so that I can keep making these journeys into the strangest truths the universe has to offer. Now, settle in and get yourself comfortable. Let's begin. There is something deeply human about looking up at the night sky and imagining leaving. Not just leaving Earth, not just leaving the solar system, leaving everything. Pushing outward past the last familiar star, past the spiral arms, past the faint halo of ancient suns orbiting in the galactic outskirts, and finally breaking free of the Milky Way itself. Sailing out into the black gulf between galaxies, arriving somewhere else, somewhere unimaginably far away, somewhere new. This is not just science fiction fantasy. It is the logical extension of every real achievement in human exploration. We left Africa, we crossed oceans, we reached the poles, we walked on the moon. We sent robots to Mars and probes past the outermost planets. Voyager 1, launched in 1977, is right now more than 15 billion miles from Earth, drifting through interstellar space, still transmitting data back to us across a void so vast that its radio signals take nearly 24 hours to arrive. In late 2026, it will officially cross the one light day threshold, the first human-made object to reach that distance. Every generation pushes the boundary a little further, and every time we push it, the next boundary comes into view. So the dream feels reasonable, inevitable even. If we can survive long enough, develop the right technologies, build the right ships, surely we will eventually spread outward through the galaxy and beyond it. Surely no distance is permanently beyond reach for a species that refuses to stop moving. But here is where the dream begins to distort. Because most people who imagine escaping the Milky Way have never truly confronted what the Milky Way is. Not the postcard version, not the pretty spiral diagram on a classroom wall, not the neat little label that says 100,000 light years across, as though that number means something your brain can hold. The real Milky Way, the one that exists in actual, physical space, measured in distances so extreme that they make every other scale in human experience vanish into irrelevance. To understand why no human civilization could ever meaningfully escape this galaxy, you first need to understand what this galaxy actually is. And that requires dismantling almost everything your intuition tells you about size, distance, and time. Start with the basics. The Milky Way is a barred spiral galaxy. It contains somewhere between 200 billion and 400 billion stars. The uncertainty in that number is itself staggering. We are unsure about the population of our own galaxy by a margin of 200 billion stars, because dust clouds block our view. Dim red dwarfs are nearly invisible at great distances, and we are trying to count the contents of a structure from the inside. The stellar disk, the flat spinning plane where most of those stars reside, stretches roughly 100,000 light years from edge to edge. Some more recent measurements push that figure closer to 170,000 or even 200,000 light years, when you include the sparse outer regions where stars thin out gradually, rather than stopping at a clean border. The galaxy does not have a sharp edge. It fades. Stars become fewer and fewer as you move outward, but they never quite disappear into a definite boundary. Beyond the stellar disk lies the galactic halo, a vast spherical region of old stars, globular clusters, and an enormous quantity of dark matter. The dark matter halo alone may extend to nearly 1 million light-years in diameter based on certain gravitational models. A 2020 study estimated the edge of the Milky Way's dark matter halo at roughly 950,000 light-years in diameter, plus or minus about 200,000 light-years. That means the full gravitational footprint of our galaxy reaches nearly halfway to Andromeda. But for the purposes of understanding escape, focus on the stellar disk. 100,000 light-years across. That is the structure you would need to cross just to reach the outer boundary of the galaxy's visible stars, not to escape into intergalactic space, just to get to the edge. 100,000 light-years. Let that number settle for a moment before we tear it apart. A single light-year is approximately 5.88 trillion miles. That is not a typo, and it is not an exaggeration. Light, the fastest phenomenon in the known universe, covers 186,000 miles every second. In a single year of relentless travel at that speed, it crosses roughly 6 trillion miles. 100,000 light-years, then, is 600 quadrillion miles. If you wrote that number out in full, it would have 18 digits. But raw numbers do not create understanding. The human brain did not evolve to process distances beyond the horizon. We developed spatial intuition to navigate savannas and river valleys, not galactic structures. So let us try to build a sense of this scale from something closer to home. Consider the distance from Earth to the Sun, about 93 million miles. This distance is called 1 astronomical unit, and it is the fundamental yardstick of our solar system. Light crosses that gap in approximately 8 minutes and 20 seconds. Now, consider the distance from Earth to Pluto at its farthest orbital point, roughly 50 astronomical units. Light takes about 7 hours to make that trip. Voyager 1, the most distant human-made object in existence, is currently about 166 astronomical units from the Sun. It has been travelling for nearly 48 years at roughly 38,000 miles per hour. And in all that time, covering all that distance, it has crossed less than 1/300th of a single light-year. Hear that again. 48 years of continuous travel at 38,000 miles per hour, and the result is a fraction so small that it barely registers against the length of 1 light-year. The distance to the nearest star, Proxima Centauri, is approximately 4.2 light-years. At Voyager, one's current speed, reaching it would take roughly 74,000 years. That is longer than the entirety of modern human civilization, longer than the oldest known cave paintings, longer than every empire, every language, every written record combined, and Proxima Centauri is the nearest star. It is, cosmically speaking, right next door. It sits so close to us that on the scale of the Milky Way, the gap between our Sun and Proxima Centauri is like the thickness of a single sheet of paper measured against the length of a football field. The Milky Way contains hundreds of billions of stars scattered across 100,000 light-years, and Proxima Centauri is only 4 light-years away. We cannot reach it in any human lifetime using anything resembling current technology. This is the first fracture in the dream. The distance to the nearest star is already overwhelming. The distance across the galaxy is not merely larger. It is larger by a factor that moves the problem into an entirely different category of reality. If the distance to Proxima Centauri were represented by a single step, one ordinary human stride of about 3 feet, then crossing the Milky Way at the same scale would require roughly 24,000 steps, about 13 miles, a half marathon. That might sound almost manageable until you remember what each step represents. Each stride covers a distance that would take our fastest outbound spacecraft 74,000 years to cross. The galaxy asks you to chain together 24,000 of those impossible journeys, back to back, without a single break. Every star in the galaxy separated from its neighbours by gaps that already defeat our fastest spacecraft. and a straight line across the galaxy threading through roughly 25,000 of those gaps, one after another, across a structure so vast that light needs 100 millennia to cross it. But we are not done, because even saying light needs 100,000 years does not land the way it should. We throw around the phrase speed of light as though it is merely very fast. It is not merely very fast. It is the absolute upper limit of causality in our universe. Nothing that carries information, energy, or mass can travel faster. No signal, no ship, no force of any kind. This is not an engineering limitation waiting to be solved. It is woven into the structure of space-time itself, confirmed by more than a century of experimental physics, from particle accelerators to GPS satellites to the behavior of distant supernovae. General relativity and special relativity both depend on it. Every working piece of modern technology that involves electromagnetic radiation depends on it. The speed of light is not a speed record. It is a law, and that law says the Milky Way is 100,000 years wide. Think about what that means in human terms. 100,000 years ago, Homo sapiens had only recently migrated out of Africa. Neanderthals were still alive. No human being had yet set foot in the Americas, Australia, or most of the Pacific Islands. Language may not have reached its modern complexity. Art was in its infancy. Agriculture did not exist. Writing would not be invented for another 95,000 years. If a beam of light had left one edge of the Milky Way at the moment the first human civilizations appeared in Mesopotamia, that beam would still be in the earliest stages of its crossing today. Barely 5% of the way across. The galaxy is so large that all of recorded human history, from the first written word to the International Space Station, represents a tiny fraction of the travel time of a single photon crossing it. Now place a civilization inside that structure. Not a village, not a nation, a civilization. A coherent social and technological entity with shared language, shared governance, shared knowledge, shared identity. And ask it to cross. Even if that civilization could somehow travel at the speed of light, which no known physics allows for anything with mass, the crossing would take 100,000 years. During that time, every person who began the journey would die. Their children would die, their grandchildren and great-grandchildren, and every descendant for thousands of generations would live and die inside the vehicle. By the time the far side of the galaxy was reached, the civilization that launched the mission would be unrecognizable. Its language would have shifted beyond comprehension. Its culture would have mutated through more generations of change than separate the earliest Homo sapiens from you. The people arriving at the destination would share virtually nothing with the people who departed, except perhaps some trace of genetic ancestry buried under 100,000 years of drift and adaptation. And this is at the speed of light. The most optimistic scenario physics permits. At more realistic speeds, the numbers become genuinely difficult to process. Suppose a future civilization achieves 10% of light speed. This is far beyond anything humanity can currently build. The fastest spacecraft ever launched, the Parker Solar Probe, reached speeds of about 400,000 miles per hour during its closest solar approaches. 10% of light speed is roughly 67 million miles per hour, 167 times faster than the Parker Solar Probe. A technological leap so enormous it has no precedent in history. Even at 10% of light speed, crossing the Milky Way takes 1 million years. 1 million years. That is roughly 3 times longer than Homo sapiens has existed as a species. It is longer than our species has existed by a factor that swallows all of human history, all of human prehistory, and most of human evolution into a single transit. A civilization attempting to cross the galaxy at 10% of light speed would need to sustain itself, its technology, its social structures, and its biological population for a duration that exceeds the entire evolutionary arc of modern humanity. Now reduce the speed further, to something merely ambitious rather than miraculous. 1% of light speed, about 6.7 million miles per hour, Crossing the galaxy now takes 10 million years. That is longer than the time since the human lineage first diverged from the ancestors of modern apes. Every step in the evolution from tree-dwelling primates to spacefaring civilization would fit inside the transit time, with millions of years to spare. An entire chapter of primate evolution would pass before the crossing was complete. At Voyager 1's actual speed of approximately 38,000 miles per hour, crossing the galaxy would require roughly 1.7 billion years. That is longer than complex multicellular life has existed on this planet. The entire Cambrian explosion, the age of dinosaurs, the rise and fall of every terrestrial ecosystem, every ice age, every mass extinction, every tectonic rearrangement of the continents, all of it would fit inside the transit time. These are not speculative scenarios, they are arithmetic. Distance divided by speed equals time. And the answers are so extreme that they stop being engineering challenges and start becoming existential ones. The problem is not how to build a faster engine. The problem is that the galaxy is so large that even absurdly fast travel produces journey times measured in geological epochs. And no civilization in human history has survived for more than a few thousand years in a continuous recognizable form. The Roman Empire lasted roughly 5 centuries in the West. The Chinese dynastic system persisted in various forms for about 2,000 years. The oldest continuous institutions on Earth, certain religious traditions and a handful of monarchies, measure their histories in centuries or low millennia. No human political entity, no cultural tradition, no language, no technology base has survived intact for even 10,000 years. The idea that a civilization could maintain coherence across 1 million years, let alone 1 billion, is not merely optimistic. It is without any precedent in anything we have ever observed about how human societies actually behave. And yet, the galaxy demands exactly that. 100,000 light-years of space asks any civilization attempting to cross it to hold together for timescales that make the entirety of recorded history look like a single heartbeat. This is the first and most important thing to understand about the Milky Way. It is not a container that humanity will eventually outgrow. It is not a room that a sufficiently advanced civilization will one day walk out of. It is a structure so large that the very concept of a single, continuous, recognizably human civilization spanning it begins to dissolve under the weight of the distances involved, not because the physics are exotic, not because the engineering is impossible, but because the timescales required for even the most optimistic transit scenarios exceed every known duration of civilizational continuity by orders of magnitude. The Milky Way is not a boundary that can be broken with better rockets. It is a landscape so vast that it breaks the thing trying to cross it, not the ship, the civilization, and we have not even left the galaxy yet. Everything described so far, every crushing distance, every impossible timescale, applies only to traversing the Milky Way from the inside, reaching the far edge of our own galactic disk. The actual escape, the leap from the Milky Way into intergalactic space and onward to another galaxy, requires confronting distances that make the Milky Way itself look like a backyard. The nearest major galaxy, Andromeda, lies approximately 2.5 million light-years from Earth. That is 25 times the diameter of the Milky Way. If crossing our galaxy at the speed of light takes 100,000 years, reaching Andromeda at the same speed takes 2.5 million years. At 10% of light speed, the journey takes 25 million years. At 1%, 250 million years. At Voyager speed, roughly 42 billion years, which is more than 3 times the current age of the universe. These numbers are not hidden, they are not controversial, they are not speculative. They are the simple, confirmed observational distances between our galaxy and its nearest large neighbour, combined with the straightforward mathematics of speed and time. And they produce results so extreme that the word impossible starts to feel not like an exaggeration but like an understatement. but Andromeda is the closest major galaxy. The local group of galaxies, the gravitationally bound collection that includes the Milky Way, Andromeda, Triangulum, and several dozen dwarf galaxies, spans roughly 10 million light-years. Beyond the local group, the nearest large galaxy cluster, the Virgo cluster, sits 54 million light-years away. Beyond Virgo, the cosmic web stretches outward across billions of light-years, with voids between galaxy clusters spanning hundreds of millions of light-years of nearly empty space. Each step outward from the Milky Way multiplies the distance by factors so large that the previous scale becomes trivial by comparison. Reaching another star is hard. Crossing the galaxy is almost inconceivably harder. Escaping the galaxy into intergalactic space is harder still, by a factor of 25 or more. And reaching anything beyond the local group requires distances that would make the entire Milky Way crossing look like a brief commute. This is the trap that most people fall into when they imagine escaping the galaxy. They picture it as the next step, the natural progression. First the Moon, then Mars, then another star, then across the galaxy, then out. Each step bigger than the last, but fundamentally the same kind of challenge, just scaled up. A longer road, but still a road. It is not a road. Each transition is not merely farther. It is categorically different. The jump from interstellar to galactic travel is not like the jump from driving across town to driving across the country. It is like the jump from walking across your living room to walking to the moon. The physical act might use the same muscles, but the scale transforms the challenge into something unrecognizable. And the jump from galactic to intergalactic travel is another transformation of the same kind. If crossing the galaxy is walking to the moon, then reaching Andromeda is walking to Mars. The metaphor itself starts breaking because the language of human experience does not contain concepts large enough to map onto these distances without distortion. This is where the illusion lives. In the comfortable assumption that distance is just distance, that more of it simply means more effort, more fuel, more time, but not a fundamentally different kind of problem. The Milky Way does not work that way. The universe does not work that way. At a certain point, the sheer volume of space and time required for transit stops being a quantitative challenge and becomes a qualitative one. It changes the nature of what is being attempted. You are no longer asking whether a civilization can build a fast enough ship. You are asking whether a civilization can survive long enough to use it, whether it can remain a civilization at all across the timescales the journey demands, whether the people who arrive at the destination bear any meaningful connection to the people who departed. The Milky Way looks like a home from the inside, a vast, spiraling city of stars that we have spent centuries mapping and studying and dreaming about exploring. But the moment you try to measure it honestly, the moment you lay the real numbers next to the real capacities of real civilizations, the galaxy reveals itself as something else entirely. Not a home to be outgrown, not a cradle to be left behind, but a structure so immense that it already exceeds the scale at which the word civilization retains its ordinary meaning. And that is just the inside. The outside is worse, much worse. Most visions of humanity's cosmic future follow a neat progression. First, we become a spacefaring species within our own solar system. Then we reach the nearest stars. Then we spread outward from star to star, building colonies, establishing trade routes, expanding the frontier. Eventually, after enough centuries or millennia of steady growth, the wave of expansion reaches the edge of the galaxy and spills over into intergalactic space. The whole picture has a comforting logic to it. Each step leads naturally to the next. Each challenge is merely a larger version of the one before it. This vision is wrong. Not because the individual steps are impossible, but because the ladder itself breaks. The progression from interstellar travel to galactic travel to intergalactic travel is not a smooth continuum. Each transition represents a qualitative leap so severe that the skills, technologies, and civilizational structures required for one level become almost meaningless at the next. The difference between reaching another star and crossing a galaxy is not the difference between a short trip and a long one. It is the difference between swimming across a river and swimming across the Pacific Ocean. The motion is the same, the medium is the same, but one of them will kill you, and the reason it will kill you has nothing to do with your swimming technique. To see why the ladder breaks, you need to look carefully at each rung, not at the theoretical physics, at the actual physical, measurable reality of what each journey demands. Begin with the first rung, reaching another star. Alpha Centauri, the nearest star system, sits approximately 4.2 light-years from Earth. In absolute terms, this is an almost incomprehensible distance, roughly 25 trillion miles. But in galactic terms, it is essentially nothing, a speck, the gap between two neighbouring grains of sand on a beach that stretches across a continent. Humanity has never sent anything to another star. The fastest outbound object we have ever built, Voyager 1, would need roughly 74,000 years to cover the distance to Proxima Centauri if it were aimed in that direction. But serious proposals exist for reaching nearby stars within shorter timescales. Breakthrough Starshot, a research initiative funded in 2016, proposed using powerful ground-based lasers to accelerate tiny, gram-scale probes on light sails to approximately 20% of the speed of light. At that velocity, a probe could reach Alpha Centauri in about 20 years. It would carry no crew. It would weigh less than a paperclip. It would fly past its target in seconds, snapping photographs and transmitting data back to Earth over a journey of another 4 years at light speed. But it would get there. Larger concepts push harder. Project Daedalus, a 1970s study by the British Interplanetary Society, designed an uncrewed fusion-powered probe capable of reaching Barnard's star, about 6 light-years away. In roughly 50 years, its cruise speed would have been approximately 12% of light speed. The spacecraft would have massed over 50,000 tons at launch, most of it fuel. It was never built, but the physics checked out. More recently, Project Longshot and various fusion propulsion studies have explored similar ideas, estimating that speeds between 5 and 15% of light speed might be achievable with advanced but not fantastical engineering. For crewed missions, the numbers stretch further. A generation ship designed to carry a living population to another star would need to sustain human life for decades to centuries, depending on speed. The 2025 Project Hyperion design competition explored this challenge in detail. The winning concept, Chrysalis, proposed a cylindrical vessel roughly 36 miles long carrying 2,400 people on a 400-year journey to Alpha Centauri. 400 years. Roughly 16 generations of human beings living, reproducing, aging, and dying inside a single vessel before anyone sets foot on a new world. This is the first rung of the ladder. It is already extraordinary. It demands propulsion technology far beyond anything currently operational, life support systems of unprecedented reliability, and social structures capable of surviving intact for centuries inside a closed environment. No human society has ever attempted anything remotely comparable, but at least the challenge is imaginable. 400 years is a long time, but it is within the range of durations that human institutions have occasionally survived. The Roman Catholic Church is older. Some indigenous Australian cultural traditions are vastly older. 400 years is brutal, but it does not automatically destroy the concept of continuity. Now, step onto the second rung, crossing the galaxy. Suppose a civilization has already mastered interstellar travel. It can send ships between nearby stars at 10% of light speed, a remarkable achievement. It has established colonies around dozens, maybe hundreds of stars within a few hundred light-years of Earth. Each colony took decades or centuries to reach. Each required enormous investment, but the civilization is growing, expanding, pushing outward. Now ask that civilization to cross the Milky Way. The stellar disk is approximately 100,000 light-years wide. Our solar system sits roughly 26,000 light-years from the galactic center, embedded in one of the outer spiral arms. The far edge of the galaxy lies roughly 74,000 light-years from us. The near edge, back toward the center and out the other side, is a comparable distance. At 10% of light speed, traversing 74,000 light-years takes 740,000 years. Traversing the full diameter takes 1 million years. This is not just a longer version of the Alpha Centauri trip. It is a fundamentally different kind of problem. At 400 years, you are asking a ship's crew to maintain continuity across 16 generations. At 740,000 years, you are asking a civilization to maintain continuity across roughly 30,000 generations. 30,000 successive cohorts of human beings, each one born inside a vessel or a chain of colonies, each one tasked with passing knowledge, purpose, and direction to the next. 30,000 handoffs of language, culture, technology, and intent, with zero margin for catastrophic failure at any point along the chain. For comparison, 30,000 generations ago, anatomically modern humans were not meaningfully different from us biologically, but they had no agriculture, no writing, no metal tools, no permanent settlements. 30,000 generations represents a span of time across which every feature of human civilization, from the first domesticated grain to the latest semiconductor, was invented, lost, reinvented, transformed, and replaced. The idea that a cultural mission, a shared sense of purpose and identity, could survive that many successive transfers without dissolving into something entirely different is not supported by any evidence from human history. It is a hope projected onto timescales where hope has no empirical footing. At this point, an informed listener might raise an objection. What about time dilation? Einstein's special relativity tells us that time passes more slowly for objects moving at high velocities relative to a stationary observer. A crew traveling at 90% of light speed would experience time at roughly 44% of the rate experienced by someone standing still. At 99% of light speed, the ratio drops further. Time aboard the ship crawls while decades and centuries pass in the outside universe. Does this not solve the problem? Could a crew not cross the galaxy in what feels like a manageable time frame, compressing hundreds of thousands of years into a few centuries of subjective experience? The physics of time dilation is real and confirmed. But it does not solve the problem. It deepens it. Time dilation compresses the journey for the traveller. It does nothing for the civilization left behind. Imagine a crew departs Earth at 90% of light speed, headed for the far side of the galaxy. On board, the crossing takes roughly 48,000 years of subjective time, a substantial compression from the 111,000 years that pass in the external frame. But on Earth and at every colony the ship passes, over 100,000 years elapse in full. Every institution that funded the mission dissolves. Every language that named the ship goes extinct. Every political system that authorized the journey collapses and is replaced, and collapses again, hundreds of times over. The travelers arrive younger than expected, but the universe they arrive into is unimaginably old compared to the one they left. The crew does not return to anything. They do not arrive at anything that was planned for them. Whatever existed at the destination when the mission was launched has had 100 millennia to change, collapse, or vanish entirely. Time dilation creates a one-way temporal exile. The travelers are cut off not merely by distance but by elapsed time. They become refugees from a past that no longer exists, arriving in a future that has no memory of them. The asymmetry is total. The traveler's clock slows down. Everyone else's does not, and time dilation only functions at speeds close to the speed of light. At 10% of light speed, the time dilation factor is negligible, roughly 0.5%. The subjective journey across the galaxy at that speed would still last very nearly 1 million years. To achieve meaningful compression, you need velocities above 80 or 90% of light speed, which demand energy budgets so colossal that accelerating even a modest spacecraft to those speeds would require harnessing a significant fraction of a star's total energy output. The fuel problem alone is staggering. A ship massing a few thousand tons, traveling at 90% of light speed, carries kinetic energy equivalent to roughly 1,000 times humanity's total annual energy consumption. Decelerating at the destination requires an equal expenditure. The engineering is not merely beyond current capability. It is beyond any reasonable extrapolation of capability for centuries to come. Time dilation does not shrink the galaxy. It merely rearranges who experiences the full weight of its scale. The travelers feel less time. The universe feels all of it. And it is the universe, not the ship, where the civilizational connections must survive. Dilation is not a solution to the fragmentation problem. It is a mechanism for making the fragmentation asymmetric, ensuring that the travelers and the civilization that launched them can never inhabit the same temporal reality again. But the challenge is not just duration and relativity. It is also energy. Every kilogram of mass you accelerate to 10% of light speed requires enormous energy. The kinetic energy of an object at that velocity follows from basic relativistic mechanics. And for a spacecraft massing even a few thousand tons, the energy budget becomes staggering. Now consider that crossing the galaxy is not a single trip. A civilization expanding outward, star by star, must accelerate and decelerate at every stop. Each hop between neighbouring stars, perhaps 4 or 5 light-years apart, requires its own propulsion budget. Crossing the galaxy means chaining together roughly 20,000 of these hops, each one demanding fuel, each one demanding infrastructure at the departure and arrival points. This is the tyranny of multiplication. A single interstellar hop is expensive but conceivable. 20,000 consecutive hops, each requiring fuel, maintenance, crew, and functioning technology, is not merely 20,000 times harder. It is exponentially more fragile because every link in the chain must hold. A single failure, a single colony that collapses, a single fuel depot that runs dry, a single generation that loses the knowledge to maintain the propulsion systems, breaks the chain entirely. And this assumes the civilization is hopping from star to star, not flying across empty space in a single vessel. A direct crossing would be far worse. The interstellar medium between the spiral arms is not uniformly populated with convenient refueling stars. There are vast stretches of the galaxy, particularly above and below the galactic plane and in the gaps between spiral arms, where stars are sparse and the distances between potential stopping points grow to tens or hundreds of light years. A ship crossing those gulfs would face centuries or millennia of transit between any two useful destinations, with no opportunity to resupply, repair, or recruit. The galaxy is not a uniformly lit room that you can walk across in a straight line. It is a structure with dense regions and sparse regions, with dust lanes that block navigation, with radiation hazards near the galactic core, with streams of ancient stars orbiting at odd angles through the halo. The topology of the Milky Way matters. Crossing it is not a geometry problem on a flat map. It is a navigation problem through a three-dimensional structure, riddled with obstacles, dead zones, and lethal environments. Consider what lies near the centre of the galaxy. Sagittarius A star, the supermassive black hole at the Milky Way's core, weighs approximately 4 million times the mass of the Sun. The region surrounding it is among the most violent environments in the galaxy. Stars orbit the black hole at thousands of kilometers per second. Intense X-ray and gamma-ray radiation floods the central parsecs. Dense molecular clouds, some containing millions of solar masses of gas and dust, crowd the inner few thousand light years, creating a maze of gravitational disturbance and electromagnetic interference. Any trajectory that passes near the galactic center would expose a vessel to radiation levels lethal to unshielded biology, gravitational tidal forces capable of disrupting orbital mechanics, and navigational hazards so dense that plotting a safe course would require knowledge of the region far more detailed than anything we currently possess. This means a direct crossing through the center of the galaxy is not merely difficult, it is functionally impassable for any crewed vessel. The realistic paths around the core add thousands or tens of thousands of light years to the journey, extending the already extreme crossing time even further. The galaxy does not offer straight lines. It offers detours through dangerous terrain, each one adding centuries or millennia to a journey already measured in geological epochs. Even in the relatively calm outer disk, hazards persist. Dense nebulae filled with molecular hydrogen can span hundreds of light years, blocking navigation and requiring either passage through opaque regions or lengthy diversions around them. Supernova remnants create expanding shells of high-energy particles and superheated gas that can persist for tens of thousands of years, rendering entire stellar neighborhoods temporarily uninhabitable. Regions of active star formation, where massive young stars burn through their fuel in a few million years before exploding, are scattered unpredictably through the spiral arms. A civilization crossing the galaxy would not traverse a benign void between stars. It would navigate a dynamic, shifting landscape of hazards that no single map could capture across the timescales involved. The Milky Way, viewed from this practical perspective, is not an open field. It is a labyrinth, one whose corridors shift and whose dangers reconfigure themselves on timescales shorter than the crossing itself. A route that was safe when the journey began might be blocked by a supernova remnant halfway through. A stellar neighborhood that offered resources 100,000 years ago might be a radiation-blasted wasteland by the time a slow-moving expansion front reaches it. Now, step onto the third rung, the one that shatters. You have crossed the galaxy. Your civilization, or whatever remains of it after 1,000,000 years of fragmented expansion, has reached the outermost edge of the Milky Way's stellar disk. Ahead of you lies the intergalactic void. This is where human intuition collapses entirely. The nearest major galaxy, Andromeda, sits approximately 2.5 million light-years away. But Andromeda is practically a neighbor. It is the closest large spiral galaxy to the Milky Way, gravitationally bound to us, drifting toward us for an eventual collision in roughly 4.5 billion years. Most galaxies are far more distant. The Virgo cluster, the nearest large galaxy cluster, is 54 million light-years away. The observable universe extends 46.5 billion light-years in every direction. Focus on Andromeda. 2.5 million light-years. At 10% of light speed, reaching it takes 25 million years. At 1%, 250 million years. At the speed of the fastest spacecraft humanity has ever launched, the Parker Solar Probe, at its peak velocity of roughly 400,000 miles per hour, the journey to Andromeda would take approximately 4 billion years. Roughly the same amount of time that remains before the Sun exhausts its hydrogen fuel and expands into a red giant. But the distance alone does not capture the true horror of the intergalactic void. It is the emptiness. Between the Milky Way and Andromeda lies a gulf that contains almost nothing. Not nothing in the colloquial sense of mostly empty. Nothing in the physical sense of a few stray hydrogen atoms per cubic meter. The intergalactic medium is the closest thing to a perfect vacuum that exists in nature. Its density is roughly 1 atom per cubic meter in the warmest regions, dropping far lower in the deepest voids between galaxy clusters. For comparison, even the best ultra-high vacuum chambers on Earth still contain roughly 10,000 molecules per cubic centimeter. Intergalactic space is emptier by a factor of billions. There are no stars in the void, no planets, no asteroids, no comets, no sources of fuel, light, heat, or raw materials. A spacecraft crossing from the Milky Way to Andromeda would spend the entire journey, millions of years of it, in a darkness more complete than any environment on Earth or in our solar system. The nearest source of energy would be the galaxy behind it, growing fainter with every passing century, and the galaxy ahead of it, still too far away to provide anything useful. This is the qualitative difference between galactic and intergalactic travel. Inside the galaxy, there are stars, hundreds of billions of them. Even in the sparsest regions of the galactic disk, you are never more than a few dozen light-years from some kind of stellar system. Stars provide energy. Planetary systems provide raw materials. A civilization hopping between stars at least has the theoretical possibility of resupplying along the way. In the intergalactic void, there is nowhere to stop. No harbour, no way station, no oasis. The journey must be completed on whatever fuel and supplies the vessel carries at departure. For a trip lasting millions of years, this means carrying everything. Every calorie of food, every molecule of oxygen, every watt of energy, every spare part, every genetic lineage needed to sustain a population. Nothing can be gathered along the way because there is nothing to gather. The engineering requirements for such a journey do not merely exceed current technology. They exceed any plausible extrapolation of future technology by margins so vast that the word impossible begins to feel inadequate. A self-sustaining vessel capable of supporting a human population for 25 million years without any external input would need to be, in essence, a planet. A closed ecosystem of extraordinary complexity, capable of recycling every atom of matter indefinitely, repairing every system failure without external parts, and maintaining biological and social stability across 1 million human generations. No closed ecosystem experiment on Earth has ever succeeded for more than a few years. Biosphere 2, the most ambitious attempt, experienced oxygen depletion, species die-offs, and social conflict among its crew within months. The International Space Station requires regular resupply missions from Earth. Even the most optimistic designs for long-duration space habitats assume external support systems within reasonable reach. A vessel in the intergalactic void would have none, and this is where the ladder truly breaks, because the problem is not just that intergalactic travel is harder than galactic travel. It is that the entire framework of assumptions behind galactic expansion, the idea of hopping from star to star, building colonies, establishing supply chains, gradually pushing the frontier outward, ceases to function the moment you leave the galaxy. There are no stars to hop to, there is no frontier to push. There is only a void so empty and so vast that it might as well be a wall. The metaphor of a ladder fails because a ladder implies continuity. Each rung connects to the next. You climb smoothly from one level to the next, without any gap. But between the galactic rung and the intergalactic rung, there is no connection, there is a chasm. The skills that carry you across the galaxy, finding stars, establishing colonies, building relay networks, become useless in a void that contains no stars, supports no colonies, and stretches for millions of light years without a single point of reference. This is why escaping the Milky Way is not the next step after crossing it. Crossing the galaxy, for all its absurd difficulty, at least operates within a recognizable paradigm. Stars exist. Destinations exist. You can imagine chaining together enough hops to eventually reach the far side, even if the timescale is geologically extreme. Escaping the galaxy abandons that paradigm entirely. It asks a civilization to leap into a void where the rules of incremental expansion no longer apply, where there is no next star, no next colony, no next step. Only a crossing so long and so empty that the civilization attempting it would need to carry its entire world with it, and sustain that world for longer than most species have ever existed on Earth. Consider one more comparison to feel. The scale. The average distance between stars in the Milky Way's stellar neighbourhood is roughly 4 to 5 light years. This is the basic unit of interstellar travel. One hop, the distance from the edge of the Milky Way to Andromeda, is 2.5 million light years. That single intergalactic crossing is equivalent to roughly 500,000 consecutive interstellar hops, laid end to end, with nothing in between. 500,000 trips to Alpha Centauri, chained together across a void with no rest stops, no refueling points, no stars, and no planets. But worse than that, because at least inside the galaxy each hop ends at a real destination where something useful exists. In the void, there is no destination until you reach the other side. The ladder does not merely become harder to climb, it vanishes beneath your feet, and this assumes you are heading toward Andromeda, the nearest large galaxy. If you chose a different direction, the distances grow catastrophically. The Virgo cluster is 54 million light-years away. At 10% of light speed, the journey takes 540 million years. The Coma cluster is roughly 320 million light-years away. Travel time at 10% of light speed, 3.2 billion years. These are no longer timescales that correspond to anything in human experience. They are timescales that correspond to the formation and destruction of entire planetary systems. Stars are born, burn through their fuel, and die as white dwarfs or neutron stars or black holes in less time than it would take to cross these distances at speeds wildly beyond anything we can currently achieve. The observable universe is 93 billion light-years in diameter. It contains roughly 2 trillion galaxies. The overwhelming majority of those galaxies are separated from the Milky Way by distances so extreme that even light itself, travelling since the Big Bang, has barely had time to cross the gaps between them. Many galaxies are receding from us faster than light due to the expansion of space, meaning they are not merely far away, but causally disconnected from us. No signal, no ship, no information of any kind can ever reach them from here, regardless of how fast it travels, because the space between us is growing faster than anything can cross it. This is the cosmic context in which the dream of escaping the Milky Way must be evaluated. Not in a universe of convenient distances and achievable timescales, but in a universe where the gaps between structures are so vast that they exceed the functional lifespan of every physical process involved in sustaining a civilization. The Milky Way is not a small pond that humanity will one day outgrow. It is an ocean, and the space beyond it is not another shore. It is the deep, open, featureless expanse that separated continents before anyone knew how to cross it. Except, this ocean has no currents to carry you, no wind to fill your sails, no islands to rest on, and no far coast that you could reach within any time frame that preserves your identity as the species that set out. The distinction between interstellar, galactic, and intergalactic travel is not a matter of degree. It is a matter of kind. Each level introduces problems that the previous level did not contain. Interstellar travel introduces timescales that challenge individual human lifespans and require multi-generational planning. Galactic travel introduces timescales that challenge the survival of entire civilizations and require continuity across geological epochs. Intergalactic travel introduces timescales that challenge the survival of species themselves and require sustaining a closed, isolated system through durations that exceed the evolutionary history of most complex life forms on Earth. Each rung of the ladder demands not just more effort, but a different kind of entity to attempt it. A nation can plan an interstellar mission. A galactic crossing might require something like a species-level project sustained across eons. An intergalactic crossing would require something that has no precedent in human experience and no analogue in human language. A self-sustaining, self-repairing, self-governing world, sealed against the void, enduring for millions of years without external contact, without resupply, without any anchor to the civilization that built it. And at the end of that journey, if it succeeded, what would arrive? Not the civilization that departed, not humans in any sense that we would recognize. Something else, something shaped by millions of years of isolation, adaptation, drift, and change. Something that would look back at the species that launched it the way we look back at the single-celled organisms that eventually gave rise to us. A common ancestor, impossibly distant, connected by an unbroken chain of descent but sharing nothing of identity, culture, or experience. The ladder breaks because the universe is not built for continuous expansion. It is built in layers, and each layer is separated from the next by distances that transform the traveller beyond recognition. The Milky Way is one layer. Reaching the next one does not mean climbing higher. It means ceasing to be what you were when you started. And between those layers lies something even more destructive than distance. Something that cannot be solved with faster engines or better life support. Something that attacks the very idea of a civilization remaining whole across the timescales the universe demands. That something is time itself, and what it does to everything human. Everything discussed so far has treated the galaxy as a distance problem. How far is it across? How long does the journey take? How much energy is required? These are engineering questions, and engineering questions have a seductive quality. They imply that somewhere, buried in the mathematics, there is a solution. Build a faster ship, find a better fuel, invent a more efficient propulsion system. The universe becomes a puzzle to be solved, and the Milky Way becomes a cage with a lock that the right technology might eventually pick. But the Milky Way is not a cage. A cage is a structure that confines you in space while leaving everything else intact. Your identity survives, your memories survive, your connection to the world outside survives. You remain who you are. You are simply stuck. The galaxy does something worse than confine. It dissolves, not the ship, not the body. It dissolves the civilization, the connections between people, the threads of shared language and shared meaning that allow a group of human beings to call themselves a single society. And it does this not through any exotic physical mechanism, but through the simplest and most merciless force in the universe. Time, applied at a scale that no human institution has ever survived. This is the fragmentation problem. And it is the reason why the Milky Way is not merely difficult to escape, but why the very concept of a human civilization escaping it may be incoherent. We do not need theory to understand how this works. History already provides a demonstration, played out on a miniature scale that nonetheless captures the essential dynamics perfectly. Roughly 3,000 years ago, a group of seafaring people began migrating eastward from the coastal regions of Southeast Asia into the vast Pacific Ocean. They carried with them a shared language, shared navigational knowledge, shared religious practices, and a common set of technologies centered around the outrigger canoe. They were a single culture, unified by blood and tradition, setting out across an ocean that would test every bond that held them together. Over the next 2,000 years, their descendants spread across the largest geographic feature on Earth. They reached Tonga, Samoa, Fiji. They pushed onward to Tahiti, the Marquesas, Hawaii. They sailed south to New Zealand and east to Rapa Nui, one of the most isolated inhabited places on the planet. By the time European explorers arrived, the Polynesian expansion had populated thousands of islands scattered across roughly 10 million square miles of open ocean. And the result was not one civilization, it was dozens. Hawaiian society was built around rigid social hierarchies and monumental temple construction. Maori culture in New Zealand developed elaborate carving traditions and complex warfare practices shaped by a colder climate. Rapa Nui produced the famous moai statues, a cultural expression found nowhere else in Polynesia. Tongan and Samoan societies, despite relative geographic proximity, developed distinct political systems and cultural identities. The languages diverged until speakers from distant island groups could no longer understand each other. Hawaiian and Maori, though both descended from the same Proto-Polynesian tongue, became mutually unintelligible. None of this happened because the Polynesians failed. It happened because the Pacific Ocean was wide enough and the voyages slow enough that the connections between island groups could not be maintained. The technology to sail between islands still existed in many cases. The knowledge that other islands were out there persisted in oral traditions. But the practical reality of crossing hundreds or thousands of miles of open water meant that contact was infrequent, unreliable, and eventually, for the most distant settlements, non-existent. Rapa Nui lost contact with the rest of Polynesia entirely. Its people developed in total isolation for centuries, unaware of the broader civilization they had once belonged to. The Pacific Ocean did not need to be uncrossable. It only needed to be wide enough and slow enough to traverse that the threads of shared identity frayed faster than they could be repaired. The Polynesians could still sail. They simply could not sail often enough, or fast enough, to prevent divergence from becoming permanent. This is exactly the dynamic that would play out across the Milky Way, except multiplied by factors so extreme that the Pacific analogy becomes almost quaint by comparison. The Pacific spans 10 million square miles. The Milky Way spans 600 quadrillion miles. The Polynesian expansion took roughly 2,000 years. A galactic expansion would take millions. The Polynesians had canoes that could cross their ocean in weeks or months. A galactic civilization would have ships that required centuries or millennia to cross even the smallest gaps between neighboring stars. If a single human culture could fragment into dozens of mutually unintelligible societies across one ocean in 2,000 years, what would happen across a galaxy in 2 million? Begin with communication. Every relationship between human beings, whether personal, political, economic, or cultural, depends on the exchange of information, conversation, correspondence, trade agreements, legal codes, scientific publications, news, gossip, shared stories, shared jokes. The flow of information is the circulatory system of any civilization. Cut it off, and the civilization does not merely weaken, it fragments into isolated pieces that begin evolving independently. Inside the Milky Way, information travels at the speed of light. Nothing faster exists. A radio signal, a laser pulse, a gravitational wave, they all propagate at the same maximum velocity, roughly 186,000 miles per second. On Earth, this speed is effectively instantaneous. A signal crosses the planet in a fraction of a second. Even in the solar system, the delays are manageable. Light takes about 8 minutes to travel from the Sun to Earth, about 4 hours to reach Neptune, roughly 23 hours to reach Voyager 1 at its current distance. These delays are annoying but workable. You can still hold a conversation, albeit a slow one. Now scale that delay to galactic distances. A signal sent from Earth to a colony 10 light-years away takes 10 years to arrive. The response takes another 10 years to return. A single exchange of messages requires 20 years. If you wanted to negotiate a trade agreement with that colony, clarify terms, resolve ambiguities, and finalize the deal, you might need 5 or 6 exchanges. That is over a century of elapsed time for a single negotiation. By the time the agreement is finalized, the people who initiated it are long dead. Their grandchildren are old. The political and economic conditions that motivated the agreement have changed beyond recognition. Now push the distance to 100 light-years. A round-trip message takes 2 centuries. At 1,000 light-years, it takes 2 millennia. At 10,000 light-years, roughly the distance from Earth to the galactic center, a single exchange of messages takes 20,000 years. That is longer than the entirety of recorded human history. A message sent from Earth today would arrive at the galactic center in roughly 26,000 years. The reply would come back 26,000 years after that. 52,000 years for one question and one answer. At these timescales, communication ceases to be communication in any meaningful sense. It becomes archaeology. By the time a message arrives, the civilization that sent it may no longer exist. The language it was written in may no longer be spoken. The political entity that authorized it may have risen, fallen, and been replaced dozens of times over. The people receiving it would have no more connection to its senders than you have to the humans who painted the caves at Lascaux. You can observe their marks, you can speculate about their meaning, but you cannot talk to them. They are gone. This means that any civilization spread across even a modest fraction of the Milky Way cannot function as a unified entity. There is no galactic government because governance requires feedback loops faster than the timescales of political change. There is no galactic economy because trade requires negotiation faster than the timescales of economic transformation. There is no galactic culture because culture requires shared experience faster than the timescales of cultural drift. What you get instead is an archipelago, a scattering of isolated settlements, each one evolving independently, each one developing its own language, its own customs, its own technology, its own understanding of the universe, connected in theory by the knowledge that other settlements exist somewhere out there in the dark. disconnected in practice by delays so enormous that no meaningful interaction between them is possible within any single human lifetime, or any 100 human lifetimes. This fragmentation is not a failure of technology, it is a consequence of physics. The speed of light is the absolute ceiling on travel, but it is also the absolute ceiling on communication. No signal of any kind, radio, laser, gravitational wave, can outrun a photon. Every message ever sent between 2 points in space is bounded by this same limit, and no experiment has ever found an exception. There is no loophole, there is no workaround. There are speculative theoretical concepts, wormholes, Alcubierre drives, quantum entanglement, but none of them has ever been demonstrated to transmit usable information faster than light, and several of them have been shown to be impossible under known physics. Quantum entanglement, often cited as a candidate for faster-than-light communication, explicitly cannot be used to send messages. The correlations it produces are real, but they carry no controllable information. This has been proven mathematically and confirmed experimentally, so the speed of light stands, and as long as it stands, the Milky Way is not a single environment. It is a vast collection of causally disconnected neighborhoods, each one limited to interacting only with its immediate surroundings on timescales that permit meaningful exchange. The radius of meaningful interaction for any settlement depends on how long that settlement can maintain continuity. A colony that endures for 1,000 years can meaningfully interact with other colonies within about 500 light-years, allowing time for a few round-trip exchanges. A colony that endures for 10,000 years can interact within about 5,000 light-years. No human institution has ever lasted 10,000 years in a continuous, recognizable form. This creates a hard ceiling on the size of any coherent human civilization within the galaxy, not a technological ceiling, a temporal one. The maximum extent of a unified civilization is determined not by how fast its ships travel, but by how long its institutions survive. And since all known human institutions have lifespans measured in centuries to low millennia, the maximum radius of a coherent galactic civilization is likely measured in hundreds to low thousands of light-years. A tiny fraction of the Milky Way's full extent. Beyond that radius, unity breaks down, not because anyone chose to break it, because the delays make unity physically impossible. You cannot govern what you cannot reach. You cannot coordinate with entities that will not receive your instructions for 10,000 years. You cannot maintain shared identity with communities whose responses to your messages will arrive long after your entire civilization has been replaced by something new. Now layer a second problem on top of the communication. Barrier. Language. Every living language on Earth changes constantly. Vocabulary shifts. Grammar evolves. Pronunciation drifts. The English spoken 500 years ago, the English of Shakespeare, is already difficult for modern speakers to pass without training. The English spoken 1,000 years ago, Old English, is effectively a foreign language. The language spoken 2,000 years ago by the ancestors of English speakers, Proto-Germanic, is entirely unrecognizable. Go back 5,000 years and you reach Proto-Indo-European, a reconstructed language that is the common ancestor of most European and South Asian languages, but which no modern speaker of any of its descendants could understand without years of specialized study. This rate of change is not optional. It is an intrinsic property of how human languages function. Languages change because the people who speak them change. New generations introduce new slang. Contact with other communities introduces borrowed words. Geographic separation allows different dialects to diverge until mutual intelligibility is lost. Political and cultural shifts reshape vocabulary and syntax. No human language has ever remained stable for more than a few centuries without deliberate institutional effort, and even with such effort, the underlying spoken language continues to evolve beneath the official standard. Now project this process onto the timescales of galactic expansion. A colony established around a distant star would begin linguistic divergence from the moment of departure. Within 500 years, its language would be noticeably different from the language spoken on Earth. Within 2,000 years, it would be a separate language entirely. Within 10,000 years, it would be as different from Earth's language as Mandarin is from Swahili. Within 50,000 years, any resemblance would be purely coincidental. A civilization spread across the galaxy would not speak one language. It would speak millions of languages, each one comprehensible only within its own local neighborhood. Communication between distant regions would require not just bridging the light-speed delay, but bridging a linguistic gap so vast that translation might be impossible. Languages do not just change their words, they change their conceptual categories. The way speakers of different languages perceive time, space, causality, and social relationships can differ in ways that resist simple translation. A language that has evolved in isolation for 100,000 years might encode reality in ways so alien to Earth-derived languages that no dictionary could bridge the gap. Language is not a superficial feature of civilization. It is the medium through which all other features are transmitted. Laws are written in language. Scientific knowledge is recorded in language. Cultural values are expressed in language. When language diverges beyond mutual intelligibility, every other form of shared civilization diverges with it. Law becomes local. Science becomes local. Culture becomes local. The idea of a single galactic civilization sharing a common body of knowledge, a common legal framework, a common cultural identity evaporates as completely as the language that once carried it. Add a third layer. Biology. Human beings are biological organisms subject to evolution. Evolution operates through mutation, natural selection, genetic drift, and gene flow. In a large, interconnected population, gene flow between subgroups prevents significant divergence. People in one region interbreed with people from neighboring regions, mixing genetic material and maintaining a relatively homogeneous species. In a population fragmented across galactic distances, gene flow stops completely. A colony around a distant star has zero genetic exchange with Earth or with any other colony beyond its immediate neighborhood. From the moment of separation, the colony's gene pool begins diverging. Random mutations accumulate differently than they do on Earth. Natural selection acts differently because the environment is different. Gravity, radiation levels, atmospheric composition, day length, diet, all of these vary between worlds, and all of them exert selective pressure on biology. Genetic drift? The random fluctuation of gene frequencies in small populations operates more powerfully in isolated colonies than in large connected populations. If a colony starts with a few thousand individuals, rare alleles can become common and common alleles can disappear through sheer chance. Over thousands of generations, these random changes accumulate into significant biological differences. The timescales involved in galactic expansion make this not a subtle effect but a transformative one. Significant evolutionary divergence in isolated human populations can occur in as little as 10 to 20,000 years. The differences between modern human populations on Earth, which have been separated for at most 70,000 years and have maintained some degree of gene flow throughout, are relatively small. But those populations were separated by continents, not by light years. They occasionally reconnected. They traded genes through migration and intermarriage. Galactic colonies would have no such reconnection. Separated by distances that make physical contact impossible for millennia, each colony would evolve independently. Within 100,000 years, colonial populations would likely differ from Earth humans as much as Neanderthals differed from Homo sapiens. Within 1,000,000 years, they might be as different as humans are from chimpanzees. After 10 million years of isolated evolution in radically different environments, the descendants of human colonists might not be classifiable as the same genus, let alone the same species. This is not speculation. It is the straightforward application of known evolutionary biology to the conditions that galactic expansion would create. Isolated populations in different environments diverge. The rate of divergence depends on population size, environmental pressure, and time. Galactic timescales provide all three in extreme abundance. The result is not a single human species spread across the stars, but a radiation of descendant species, each adapted to its local world, each as alien to the others as any two unrelated species on Earth. The civilization that set out from Earth would not remain human in the biological sense. It would shatter into 1,000 separate lineages, each evolving along its own trajectory, each losing any meaningful biological connection to the others. Interbreeding between distant colonies would be impossible, not just because of distance, but because the populations would no longer be genetically compatible. They would be separate species, separate genera, eventually separate orders of life. Now combine all three layers: communication delay that prevents coordination, linguistic drift that prevents understanding, biological divergence that prevents even recognizing each other as kin. These three processes operate simultaneously, reinforcing each other. A colony that cannot communicate with Earth drifts linguistically, which accelerates cultural divergence, which reduces any motivation to maintain contact, which deepens the isolation, which accelerates biological divergence. The feedback loops are all positive, all pointing in the same direction, toward fragmentation, toward separation, toward the complete dissolution of any shared identity. And these are not the only forces at work. Consider technological drift. A colony that develops its technology independently for 10,000 years will not arrive at the same solutions as Earth. Different environments demand different tools. Different resources enable different engineering traditions. A world with abundant heavy metals might develop one technological paradigm. A world rich in organic compounds but poor in metals might develop something completely different. Over tens of thousands of years, these independent technological traditions would diverge as completely as the languages and the biologies. Consider political drift. Every human society in history has undergone political change on timescales of decades to centuries. Democracies become autocracies. Empires dissolve into feudal fragments. Religions rise and fall as organizing principles. A colony separated from Earth by 10,000 light-years would undergo political evolution entirely independently of Earth's politics. Within a few centuries, its form of governance would bear no resemblance to whatever system it departed under. Within a few millennia, its political history would be as rich and as varied as all of Earth's political history combined, and entirely disconnected from it. Consider values, and the moral and ethical frameworks that a civilization operates under are not static. They change, sometimes rapidly. The values of 21st century Western democracies would be nearly unrecognizable to the citizens of ancient Rome, despite a direct line of cultural descent. The values of a colony that has been evolving its culture independently for 50,000 years would be as alien to Earth's values as the values of an entirely different species. Because they would be the values of an entirely different species. The generation ship research community has grappled with a microscopic version of this problem. Even for a 250-year interstellar voyage, studies have highlighted severe challenges in maintaining cultural knowledge, technical skills, and social cohesion across just 10 generations. Science fiction treatments of generation ships almost universally depict cultural collapse, knowledge loss, and social fragmentation long before the destination is reached. The dystopia is not a pessimistic choice by the authors. It is the natural extrapolation of everything we know about how human societies behave in isolation. A 2025 analysis published through the Centauri Dreams project noted that no industrial revolution technology has operated without repair of parts for more than a few decades, that even our most durable space probes would not function reliably for 250 years, and that the psychological and sociological challenges of confining a small population in an artificial environment for multiple generations remain largely unsolved. These concerns apply to a single ship on a single interstellar journey lasting a few centuries. Scale them to a galactic civilization attempting to maintain coherence across millions of years, and they become not challenges to be overcome, but certainties of dissolution. But the research reveals an even more intimate form of fragmentation, one that does not require galactic distances to manifest. It requires only time. The generation ship literature consistently identifies a psychological crisis that emerges in the middle generations of any multi-generational voyage. The first generation chose to go. They carry the emotional weight of the mission, the memory of Earth, the sense of purpose that comes from making an irreversible decision. The last generation will arrive. They inherit the reward, the new world, the fulfillment of the original promise, but the generations in between chose nothing and will receive nothing. They were born into a vessel they never asked to board, travelling toward a destination they will never reach, carrying out a mission designed by ancestors who are long dead for the benefit of descendants who do not yet exist. This is not a theoretical concern. Every serious study of multi-generational space habitats identifies motivation decay as among the most dangerous threats to mission survival. The middle generations have no personal stake in the outcome. Their entire lives are spent in transit, in service to a plan they did not make and a goal they will not witness. The psychological burden of that purposelessness, of being a means rather than an end, has no parallel in human experience except perhaps in the most rigidly stratified caste societies, and even those offered the consolation of a shared world outside the hierarchy. On a generation ship, there is no outside. There is only the vessel. And the generations born into it must find reasons to maintain systems they did not build, preserve knowledge they did not discover, and sustain a cultural mission they did not choose. History offers little reason for optimism here. Utopian colonies on Earth, from the Shakers to various 19th century socialist communes, almost universally failed within a few generations, even when members could leave and recruits could join. A generation ship offers neither escape nor reinforcement. It is a closed system, and closed social systems have a dismal track record. Now project this psychological fragmentation across galactic timescales. A civilization expanding outward from star to star does not just face the external forces of distance and delay. It faces the internal forces of generational disconnection. Each new generation at the frontier is further removed from the original purpose. Each new colony is founded by people who remember less and care less about the civilization that launched the expansion. Within a few centuries, the frontier colonies are not expanding on behalf of Earth. They are expanding on behalf of themselves, for reasons that have nothing to do with the original mission. The expansion continues, but the purpose behind it has been replaced, quietly, generation by generation, until nothing of the original intent remains. The fragmentation problem reveals something crucial about what the word civilization actually means. A civilization is not a collection of atoms arranged in a particular pattern. It is a network of relationships. Relationships between people, relationships between ideas, relationships between institutions and traditions, and shared memories. These relationships require maintenance. They require communication, they require renewal. When the communication stops, the relationships decay. When the relationships decay, the civilization dissolves, not into nothing, into many separate things, each one alive, each one functional, each one developing its own relationships and its own identity, but none of them connected to each other in any way that deserves the name unity. A human civilization that expanded across the Milky Way would not remain one civilization. It would become 1,000,000 civilizations, or 10 million, each one occupying its own small region of the galaxy, each one separated from its neighbors by communication delays measured in centuries or millennia, each one speaking its own languages, following its own customs, operating under its own laws, worshipping its own deities, or following its own philosophies, composed of organisms that might not even be recognizably human anymore. The galaxy could be full of the descendants of Earth, and those descendants could be so fragmented, so divergent, so alien to one another, that the fact of their common origin would carry no more practical significance than the fact that all life on Earth shares a common ancestor in some ancient single-celled organism, true in the abstract, meaningless in practice. This is why the phrase escaping the Milky Way hides a deep confusion. Escape implies a single entity moving from one place to another, a prisoner leaving a cell, a traveller crossing a border. The entity that escapes is the same entity on both sides. It carries its identity through the transition, but the Milky Way does not permit that. No distance can be bridged when the bridge takes longer to cross than the civilization building it can survive. No unity can be maintained when every channel connecting its parts decays faster than it can be renewed. Anything that attempts to cross the galaxy as a single, continuous civilization will arrive at the other side as something entirely different. Not because it failed, not because it made mistakes, but because the universe does not allow coherent identity to survive intact across the timescales the galaxy demands. You can move matter across the Milky Way. You can send atoms and molecules and perhaps even living organisms from one side to the other if you are patient enough and resourceful enough. But you cannot move a civilization. A civilization is not made of atoms. It is made of connections, and connections dissolve across distances that make maintenance impossible. This distinction is the key to everything that follows, because when people imagine escaping the Milky Way, they imagine humanity doing it. A recognizable human civilization, carrying forward the knowledge and culture and identity of Earth, pushing outward past the galactic boundary and into the void beyond. They imagine continuity, a thread of shared meaning stretching from the first campfire on the African savanna to the first colony in another galaxy, an unbroken story. The fragmentation problem reveals that this thread cannot hold, not because it is weak, but because the distances across which it must stretch are measured in hundreds of thousands of light years, and no thread of shared meaning has ever survived across even a fraction of the timescales those distances impose. What reaches the edge of the galaxy, if anything ever does, will not be us. It will not be our civilization. It will not carry our languages or our values or our memories or our biology. It will be something new. Something born from us but shaped by 1,000,000 years of independent evolution in conditions we cannot predict. Something that might look back at Earth, if it remembers Earth at all, with the same detached curiosity that we feel when we look at the first fossil traces of multicellular life in ancient rock formations. Interesting, relevant in some deep ancestral sense, but not ours, not connected to us in any way that matters. And even that transformed descendant, standing at the edge of the galaxy after 1,000,000 years of expansion, would face the intergalactic void, 2.5 million light-years of empty darkness stretching toward Andromeda, a crossing that would take longer than the entire journey that brought it to the edge. A void that would fragment whatever arrives at the far side even further, beyond all recognition, beyond all recovery. The Milky Way does not need walls to contain a civilization. It has something far more effective. It has scale. Scale so vast that it turns the passage of time from a neutral medium into a corrosive force that dissolves every bond, every connection, every shared meaning that makes a civilization rather than a scattering of unrelated parts. The question is not whether humanity could physically place objects outside the Milky Way. A sufficiently powerful launch could send a probe into intergalactic space. Hypervelocity stars, flung by interactions with the supermassive black hole at the galactic center, are already leaving the Milky Way at speeds exceeding 1,000,000 miles per hour. Matter escapes the galaxy all the time. But matter is not civilization, and the distinction between the two is everything. Stand on Earth and look up. The night sky appears intimate. Stars seem close enough to reach, clustered together like lanterns strung across a low ceiling. The Milky Way itself, that faint, luminous band arching overhead, looks like something you could walk toward, something you could enter more deeply, the way you might walk deeper into a forest. The whole scene whispers accessibility. It says the universe is out there, waiting, and all you need is the will and the means to go. This is the oldest and most dangerous illusion in astronomy. The sky lies to you. It compresses 100,000 light-years of three-dimensional structure into a flat dome that fits inside your field of vision. It hides the emptiness between stars behind the brightness of the stars themselves. It erases depth, erases distance, erases time. It presents the galaxy as a destination rather than what it actually is. A volume of space so vast that it transforms every human concept of unity, continuity, and identity into something fragile and temporary. Everything in this story has been building toward a single realization. Not that the Milky Way is large, although it is. Not that the distances beyond it are extreme, although they are. But that the scale of our galaxy is already sufficient, by itself, without invoking intergalactic distances at all, to defeat the idea of a coherent human civilization spanning it. Let us walk through the full hierarchy one final time, not to repeat the numbers, but to feel the transitions between them. To understand how each step upward does not merely add distance but transforms the nature of the problem. Earth to Alpha Centauri, 4.2 light years, at 10% of light speed, a 42-year journey. This is the domain of interstellar travel. It is genuinely difficult. It demands propulsion technology far beyond current capability, life support systems of extraordinary reliability, and either crewed vessels designed for decades of continuous operation or generation ships built for centuries. But the distances are small enough that a single human institution, a government, a corporation, a religious order, could plausibly plan and execute a mission within its own operational lifetime. The people who launch the mission might not live to see its completion, but their children or grandchildren could. The thread of continuity stretches, but it does not snap. A colony established at Alpha Centauri would be distant from Earth, but not unreachably so. Messages would take 4 years to cross the gap. Slow, but within the span of a human career. You could send a question and receive an answer before you retired. Alpha Centauri, to the far side of the galaxy, roughly 100,000 light-years. At 10% of light speed, a 1 million-year journey. This is the domain of galactic travel, and the first transformation occurs here. The challenge is no longer engineering. It is civilizational. No human institution has ever survived for 1 million years. No language has persisted unchanged for even 10,000. No political system, no cultural tradition, no technological paradigm has endured for more than a few millennia without transforming into something unrecognizable. A journey across the galaxy at 10% of light speed would outlast everything humans have ever built, everything humans have ever thought, everything humans have ever been. The entity that arrives at the far side would share an ancestral connection with the entity that departed, in the same way that you share an ancestral connection with a fish. Technically true, practically meaningless. The far side of the galaxy to Andromeda, 2.5 million light-years. At 10% of light speed, a 25 million-year journey. This is the domain of intergalactic travel, and the second transformation occurs here. The challenge is no longer even civilizational in any recognizable sense. It is biological. 25 million years is long enough for entire new orders of life to evolve. The mammals that existed 25 million years ago included the early ancestors of modern horses, elephants, and whales, but none of those modern species existed yet. The primates of that era were small, primitive monkeys and early apes with no resemblance to modern humans. 25 million years of evolution in an isolated population, subjected to the selective pressures of life inside a sealed vessel traversing intergalactic space, would produce organisms so different from the original human colonists that the word human would no longer apply, not metaphorically. Taxonomically, each transition in this hierarchy multiplies the previous distance by a factor so large that it functionally resets the problem. 4 light-years to 100,000 light-years is a factor of roughly 24,000. 100,000 light-years to 2.5 million light-years is a factor of 25. These are not incremental increases, they are categorical leaps, and each one introduces failure modes that the previous level did not contain. Interstellar travel challenges human engineering. Galactic travel challenges human civilization. Intergalactic travel challenges human biology itself. But here is the key insight. You do not need to reach the intergalactic level for the dream to collapse. The galactic level is already sufficient. Consider a civilization that has been expanding outward from Earth for 500,000 years, a long time by human standards, but only half the time required for a single crossing of the galaxy at 10% of light speed. This civilization has established colonies around thousands of stars, stretching outward in every direction. Its frontier extends perhaps 20,000 light-years from Earth, a significant fraction of the galactic disk but far short of the full diameter. What does this civilization look like? It does not look like a civilization, it looks like a gradient. Near Earth, the oldest colonies maintain some degree of connection. Their languages have diverged but are perhaps still partially mutually intelligible, the way Portuguese and Romanian are today. Their political systems have evolved independently, but may retain structural similarities inherited from common origins. Their technologies have branched in different directions but share a common conceptual foundation: move outward. At 5,000 light-years from Earth, the colonies are younger but already deeply isolated. Messages from Earth take 5,000 years to arrive. The language spoken on Earth when those messages were sent is a dead language by the time they are received. The political system that authorized them has been replaced a dozen times. The colonies at this distance have been evolving independently for thousands of years. Their languages are mutually incomprehensible. Their cultures share no common reference. Their technologies have adapted to local conditions in ways that make them alien to one another. They know, in some abstract historical sense, that they originated from the same homeworld. But that knowledge carries no more emotional or practical weight than the knowledge that all humans share a common ancestor who lived in Africa 300,000 years ago. It is a fact. It is not a bond. Move further outward. At 15,000 light-years, the colonies on the frontier are so distant from Earth that the light carrying news of their founding has not yet reached the colonies on the opposite side of the expansion sphere. Each edge of the civilization is invisible to the other. They have never exchanged a single message. They share no contemporary experience. They inhabit different regions of the galaxy, subject to different stellar environments, different radiation levels, different resource availability. Their biological populations have been diverging for tens of thousands of years. Their descendants would not recognize each other as members of the same species. This is not a civilization. It is a diaspora, a scattering of independent lineages spreading outward through the galaxy like seeds blown from a dandelion. Each seed is alive, each seed is growing. Each seed may develop into something complex and extraordinary. But no thread of shared identity connects them. The dandelion that released them is gone, dissolved into the past. What remains is a pattern of expansion without a center, a wave of colonization without a colonizer, a spreading without a self. And this is what galactic expansion actually looks like when you strip away the science fiction imagery of unified star empires and galactic federations. Those visions depend on communication faster than light, which does not exist. They depend on political institutions that endure for geological ages, which have never existed. They depend on cultural and biological stasis across timescales that guarantee change. They are fantasies built on the assumption that the universe works like a scaled-up version of Earth, where distances are large but navigable and time is long but manageable. The universe does not work that way. Distance and time are not merely obstacles to be overcome. At sufficient scale, they become forces that actively decompose the structures trying to span them. A civilization is a pattern, a complex, dynamic, self-maintaining pattern of relationships between people, institutions, technologies, and ideas. Like all patterns, it requires energy to maintain. It requires communication to sustain. It requires a minimum density of interaction to remain coherent. Spread it too thin, and it does not merely weaken. It ceases to exist as a pattern. The individual components survive, but the relationships between them dissolve, and it is the relationships, not the components, that constitute the civilization. The Milky Way is large enough to spread any human civilization past the breaking point of those relationships. Not by a small margin, by orders of magnitude. The galaxy is not slightly too large for human unity. It is so much too large that the surplus renders the question almost absurd, like asking whether an ant colony could maintain social cohesion if its members were spread across different continents with no means of communication. The answer is not just no. The answer is that the question misunderstands what a colony is, and if the galaxy alone is sufficient to destroy civilizational coherence, then escaping it is not a harder version of the same problem. It is a problem that has already been lost before the escape begins. A civilization that cannot remain unified across 100,000 light-years cannot remain unified across 2.5 million light-years. A diaspora that fragments into millions of independent lineages within the galaxy will fragment further, faster, and more completely in the void beyond it. The intergalactic crossing does not pose a new challenge. It poses the same challenge, amplified to a degree that makes the galactic version look almost manageable by comparison. This is why the title of this story is precise. Why no human civilization could ever escape the Milky Way. Not no human spacecraft, not no human probe, not no human descended organism. A probe could escape. Voyager 1, in some sense, is already escaping, or at least leaving. Hypervelocity stars are being flung out of the galaxy right now by gravitational interactions with the central black hole, and any planet orbiting such a star would go with it. Matter can leave the Milky Way. Physics does not forbid the departure of objects, but a civilization is not an object, it is a process, a continuously maintained web of interactions that generates shared meaning, shared purpose, and shared identity among its members. That process requires proximity, or at minimum, communication speeds fast enough to sustain the web across whatever distance separates its members. The speed of light provides an absolute ceiling on how fast that communication can occur, and the galaxy provides distances so extreme that the ceiling is laughably inadequate. A human civilization can exist within a small region of the Milky Way, a bubble of coherence, perhaps a few hundred light-years across, within which communication delays are short enough to permit meaningful interaction across a few human lifetimes. Such a civilization could be rich, complex, vibrant, enduring. It could last for thousands of years if its institutions were strong and its members committed, but it could not grow much larger without fragmenting, and it could certainly not span the galaxy, let alone escape it. The science fiction vision of a galactic civilization rests on an unstated assumption that technology can solve the speed of light problem, that eventually, somehow, faster than light communication or travel will be achieved, and the galaxy will shrink to manageable proportions. This assumption is not merely unsupported by evidence. It is contradicted by every relevant theory in physics. General relativity, special relativity, quantum field theory, and quantum mechanics all agree that information cannot travel faster than light in vacuum. The consistency of this limit across independent theoretical frameworks suggests that it is not a feature of our current models that better models might remove. It is a feature of reality. If faster than light travel is impossible, and every indication says it is, then the Milky Way is not a temporary cage, it is a permanent environment. The galaxy is not a structure that a sufficiently advanced civilization will one day transcend. It is the structure within which all human descendants will live forever. The relevant question is not how to escape it. The relevant question is what kind of existence is possible within it, given its true scale and the constraints that scale imposes. The answer, most likely, is local existence, small civilizations, intimate civilizations, civilizations that span a few neighboring star systems and maintain meaningful contact within that limited volume. Civilizations that know the galaxy extends far beyond their reach, but accept that the vast majority of it will never be part of their lived experience. Civilizations that define themselves not by the territory they control, but by the relationships they sustain. This is not a failure, It is a realistic accommodation of the universe as it actually exists. The fantasy of galactic empire is precisely that, a fantasy projected onto a cosmos that does not support it. The reality is both humbler and, in some sense, more beautiful. 1,000,000 small civilizations scattered through the galaxy, each one unique, each one adapted to its local conditions, each one building its own languages, its own philosophies, its own art, its own understanding of the cosmos, unconnected to each other, but each one fully alive. A garden of separate flowers rather than a single tree. But the Milky Way remains the boundary, not because of propulsion limits, not because of energy constraints, because of what distance does to time and what time does to the delicate, perishable web of connections that constitutes any civilization worthy of the name. The most terrifying truth about the universe is not that it is enormous. Enormity is abstract. You can contemplate an enormous universe with equanimity, because its vastness does not touch your daily life. The terrifying truth is more specific and more personal. It is that our galaxy, our home, the structure that contains every star we have ever seen and every world we might ever visit, is already large enough to make the concept of a unified human future dissolve into incoherence. We do not need to look beyond the Milky Way to find the wall. The wall is the Milky Way, 100,000 light-years of stars, gas, dust, and dark matter, spinning in a vast disk around a supermassive black hole. Inside it, local civilizations may rise and fall for billions of years. They may develop technologies beyond our imagination. They may build societies of extraordinary wisdom and beauty. They may seed the galaxy with descendants who thrive in ways we cannot predict, but they will not escape. Not because they cannot send objects past the galactic edge, not because the physics forbids the motion of matter into intergalactic space, but because the thing that makes a civilization, the web of relationships, the shared language, the shared identity, the sense of belonging to a common story, cannot survive the crossing. The distances are too vast, the times are too long, the forces of fragmentation are too strong and too patient. The Milky Way is not our launchpad, it is not our cradle. It is not the first chapter of a story that ends with humanity spreading across the cosmos. It is the whole story, the entire theatre within which human existence, in any form that still deserves the name, will play out. And even within that theatre, the stage is so large that most of it will remain empty. Most of the galaxy's stars will never be visited by anything descended from Earth. Most of the light years between them will never be crossed by anything carrying a human thought. The Milky Way is not too small for us. It is so unimaginably, incomprehensibly large that we could expand for millions of years and still occupy only a thin scattering of its total volume. The dream of escaping the galaxy is the dream of transcending limits. It is the same dream that drives all human exploration, the belief that every boundary is temporary, every wall is surmountable, every horizon conceals a new world waiting to be found. That dream has served us well. It carried us across oceans, it carried us to the moon, it may yet carry us to other stars. But the Milky Way is not a wall to be surmounted, it is the ground beneath our feet. We can walk across it, in the sense that we can send matter and organisms from one region to another over immense timescales. But we cannot walk past it, not because our legs are too short. Because the ground itself extends farther than any walker could ever remain the same person who started walking. The galaxy does not imprison us with force. It imprisons us with scale. It offers what looks like freedom, 100 billion stars in every direction, a vast open structure with no fences and no borders. And then it reveals, slowly, patiently, mercilessly, that openness is not the same as accessibility, that vastness is not the same as opportunity, that a prison made of distance is more secure than any prison made of walls, because walls can be broken, but distance simply waits. A human civilization cannot escape the Milky Way because the Milky Way is already too large for a human civilization to remain human while crossing it. The galaxy does not need to hold us by force. It holds us by duration. It holds us by the relentless arithmetic of light speed delay and civilizational half-life. It holds us by the certainty that nothing recognizable will survive the crossing, and that what arrives at the other side will owe nothing to what departed except the raw material of its atoms. Look up at the Milky Way tonight, that soft band of light stretching across the darkness above you. It is not a road to somewhere else. It is not a river to be followed to its mouth. It is the largest meaningful home that any human civilization will ever know. Not because the universe ends at its edge. The universe goes on, perhaps forever, in every direction, filled with more galaxies than grains of sand on Earth. But because the thing that makes us us, the fragile, beautiful, temporary web of connections that binds a civilization together, cannot stretch across the chasms that separate those galaxies. It cannot even stretch across the galaxy we already inhabit. The Milky Way is where we live. It is where we will always live. Not because we lack ambition, not because we lack ingenuity, but because the universe is built at a scale that transforms ambition into fragments and ingenuity into archaeology, and the galaxy is already more than large enough to prove it. The stars are beautiful tonight. Every one of them is ours, in the sense that they belong to the same galactic structure we do, and every one of them is forever out of reach, in the sense that reaching them will always cost more time than any civilization can pay without ceasing to be itself. That is not tragedy. That is the universe, being honest about what it is. A place so vast that even our home galaxy, one structure among 2 trillion, is already more than enough to contain every version of humanity that will ever exist. The prison is beautiful. The prison is enormous. And the prison is ours